Hi Math B, this is 7.2a lesson on absolute value functions. This is on page 29 in your lesson notes. So go ahead and pause and get that out if you haven't already, because I am going to ask you to turn in your notes. Okay, so use the equation y equals the absolute value of x to complete the following. Let's just go over what those little bars mean. Those little bars mean absolute value. So no matter what I plug in as x, the resulting value will be positive. So if I plug in -4 to here, y equals the absolute value of -4, y is just going to equal +4. If I plug in +4, it's also going to equal +4. If I plug in 1, it's going to equal 1, 0 is going to equal 0, and then you could also plug in -1 and it's still going to equal 1. When it asks to create a mapping, it's just asking us to say, what are my x values and what y values do they align with? So I'm going to write 0, 1, and 4 because I only have a couple different y values. So -4 goes with 4. 4 also goes with 4. 1 goes with 1. -1 goes with 1, and 0 goes with 0. So this is still a function because each input only has one arrow corresponding to it, so each input only has one output. Okay, now we're going to graph. So I always start my graph at 0, 0. This is going to be called a parent function eventually because we're going to see how it shifts when we change the equation. So I'm going to start right at 0, 0 because that point is in my mapping. Then I'm going to go to -1, 1, -4, 4, +1, 1, and +4, 4. And my graph is going to look something like that, and I'm going to connect the points. So as you'll notice, it creates a V shape. So it says, explain in words why it creates a V shape. So the absolute value of any positive or negative number is always going to be positive. So therefore, every single y value here is going to be positive. I'm never going to have a negative y value. That's why my line doesn't continue. It just goes back up on the other side. Does this equation represent a function? Yes, it passes the vertical line test, and each input only has one output. We kind of already talked about that. So this next one. The graph of y equals x, which we just graphed, and y equals half times x minus 2 are shown below. Complete the following. So first we need to just notice what's the same and what's different about these. Y equals x is what we just graphed on the other graph. And y equals half x minus 2. If you notice, it actually has shifted to the right, and that's because of that 2 right there. It's also a little bit wider, so it doesn't really go straight up, it goes a little bit wider like that. And it actually gives you the answer on this one. It's a little bit weird. Y equals half x minus 2 has a half in front of the absolute value symbol. So this half right there, it will make the graph wider. Okay, this -2 right there, or it's actually a +2 in our equation, but this is going to shift the graph, shifts graph to the right, and you can probably guess it shifts the graph to the right just by 2 units. I have, of course, made you guys a poster so that when we get more into these, you will have a poster to refer to for absolute value functions. But eventually we're going to get to an equation that looks like this, where before we just had y equals the absolute value of x. Now we're going to discover what each of these things does. So that -2 in there, it shifted it to the right by 2 units. This value right here will make the graph wider or narrower, or it will flip it upside down. And then this value right here will shift the graph up and down. So you can find this on my calendar. And I gave you a really big hint. Without graphing, make a prediction about how the graph of y equals negative times the absolute value of x will differ from the graph of y equals just the absolute value of x. Something to notice is that this negative is outside of the absolute value. That's really important because that's like saying y equals -1 times the absolute value of x. So your resulting answer is still going to be negative. So we're going to take the graph that we had before and just rewrite. If I were to plug in these values, they would be the same number but positive. But now if I were to plug in these values, -4, I would get a +4 when I took it out of the absolute value, but then I'd have to multiply it by -1. So it would be -4. Same thing with -2. The absolute value of -2 is 2, but I'd multiply it by -1. So all of these would actually end up being now negative numbers, because at the end, we're always going to multiply that positive number by a -1. So let's go ahead and graph this. Y equals the absolute value of x. We can go ahead and plot the same points that we did before. -4, 4, -1, 1, 0, 0, 1, 1, and +4, 4. And our graph is going to look like this. And when we graph the other one, y equals negative times the absolute value of x, we're going to go -4, now -4. -2, now -2. Still have 0, 0 on the graph. 2, +2, and +4, -4. So you can probably tell if you were to fold your paper right along the x-axis, this would have just been reflected over the x-axis. So this negative right here flips the graph over the x-axis. So you can say it reflects And I really shouldn't say over the x-axis because we're going to see graphs that move up and flip downward. So I'm just going to say it reflects down. So it flips downward. Okay, so this next one says, without graphing, make a prediction about how the graph of y equals x plus 2 will differ from the graph of y equals the absolute value of x. This would be a good time to go ahead and pause the video and actually print out this poster if you have access to that, or pull it up on my calendar so that you can see. If you'll notice, this 2 right here is inside my absolute value, and it says plus 2. My equation normally says x minus that number. So if you plug in a positive number, it's going to be minus that positive number. But if you plug in a negative number, it's actually going to be positive. So if we look at our poster, this is going to result in a horizontal shift. So it's either going to move left or right. And we can make a little table of values here. If I were to plug in -4, it would be -4 plus 2 or -2. So -4 plus 2 is going to be -2, but the absolute value of -2 is 2. The absolute value of 0 is 0. The absolute value of 2 is 2. Absolute value of 4 is 4. And the absolute value of 4 plus 2 is 6. So let's go ahead and graph this. My first point is -4 and then 2. So go over to -4 and up to 2. My next point is -2 and then 0. My next is 0, 2, and then 2, 4, and then 4 and 6. We can't really graph that, but we can see what's happened to our graph when we draw it. We can see it looks very, very similar to our original y equals the absolute value of x. The only thing that's different is my vertex, or where this point comes to the V, is shifted to the left by 2. So this number right here, we're going to say shifts the graph left by 2 units. If this then had a negative sign in front of the absolute value, like our blue one did, sometimes you'll see it'll shift the graph 2 units, and then if there was a negative sign, it would also flip it. So it would be a graph that went like this, or like the blue one, but it would start from 0, -2, 0. All right, number 7, without graphing, make a prediction about how the graph of y equals the absolute value of x plus 3 will differ from the graph of y equals the absolute value of x. Well, if we have y equals the absolute value of x, and then we add 3 to each of the y values, we can kind of think of how that's going to shift our graph. If our original graph was right here, y equals the absolute value of x is going to look like that. If I plugged in 1 as x, and then my y value now has plus 3, that's going to shift my graph up by 1, 2, 3. Here, it's going to shift my graph up by 1, 2, 3. It's going to shift my graph up here by 1, 2, 3, and my graph is going to look the same. It's just going to be shifted up by 3. So shifts graph up by 3 units. And we can go ahead and see this. If we were to plug in y equals the absolute value of -2 plus 3, -1 plus 3, 0 plus 3, 1 plus 3, and so forth, we would get now 0, 3 would be our vertex, 1, 4, and -1, 4 would be these 2 points, and then 2, 5, or -2, 5 would be those 2 points. Okay, now we're going to go down and do the graph of y equals 4 times the absolute value of x minus 3. So the first thing to think about is that if this 4 wasn't here, my -3 would shift my graph down by 3. Now we have to kind of figure out, what is this 4 going to do to my graph? So let's go ahead and actually fill out the table. If we were to plug in -2 here, it'd be 4 and then times +2 minus 3. So y would then equal 5. It would be 4 times +1 minus 3, so 1. 4 times 0 minus 3, so -3. And then you can see that there would be symmetry here. So it would also be 1 and 5. So when I graph this, I'm going to use these points and these points. So -2 and 5. We're going to graph this on the same coordinate plane. So -2, 5. 1, or I'm sorry, -1, 1. 0, -3, 1, 1, and then 2, 5. So my graph now looks like this. And as you can tell, it's shifted down by 3 units. So my vertex, or where that point comes to the V, right here, is now at 0, -3. But my graph also got a lot skinnier, or a lot more narrow. So this -4 right here makes the graph narrow, or narrower. You might be able to guess what happens when we have a 1/4 then. We have 1/4, and then we have a -1, but as you'll notice, this -1 is actually inside the absolute value. So we're going to go ahead and plug in the points that it gave us, and we're going to figure out, what does this -1 do and what does this 1/4 do? So the 1/4 times the absolute value of -3 is actually 1/4 times 3. So when we plug in those values, we should get -2 3/4, 1/2, 0 1/4, 1 0, and 2 1/4. And you can probably start to tell that when the symmetry flip-flops, like when we have 1/4 0 and then we see 1/4 again, this point is going to be the vertex or where your graph comes to that V point. So I'm going to start there at 1 0 and go ahead and graph these points. So I have 1 0. Then I have 2 and 1/4. And then I have 0 and 1/4. I have -1 1/2. I have -2 and 3/4. And we can see that our graph, it's actually hard to see because it got so much wider, but it's going to look like this. And then if we were to keep finding points on this side, it would also look like this. So that, first of all, the -1 inside the absolute value shifted it to the right by 1. And then that 1/4 made it a whole lot wider. So let's say -1 shifts to the right by 1 and then makes the graph wider. So in lieu of filling out the next page, I'm going to have you guys refer to this poster, and you can either make your own poster or you can use this poster to then fill out that next page of notes. So that's where we're going to end for this lesson.